Okay, I think now we can start. So, welcome everybody to our today's webinar with STMicroelectronics about their new Wi-Fi modules. My name is Jacob Seaman. My name is Jacob Seaman. I'm a product sales manager in the wireless department of Rutronik, mainly responsible for technologies like WLAN and RFID or NFC. Here you can see my contact information, and if you have any questions regarding these technologies or even regarding other technologies in the wireless field, please don't hesitate to contact me. Before we are going to start, I would like to encourage you to synchronize your phone with the webinar room first. I think almost everybody has done it. If not, if you look at the left side of your screen, you should see a 4-digit number under your name, which you have to type in the telephone followed by the hash key. Then your phone connection should synchronize with the webinar room, and it's easier for us to identify you in case if you have any questions. In order to make sure that we all can clearly understand the speakers, I'm now going to set you all mute. And then at the end of the webinar, I'm going to unmute you again, and we can have a question and answer session. So please, if you have any questions, write it down and wait until the end of the webinar, then we are going to answer all of your questions. Okay, I'm now going to set you on mute. Okay. Now, before we are going to start with Laura Vanzago from STMicroelectronics, I would like to say a few words about what else you can get from our wireless department at Rutronik. In this picture, you can see we are organized in mainly 4 different fields. In the first field, we have all the RFID and NFC products. For this field, we already had one very interesting webinar also with STMicroelectronics about their dual interface EEPROM with NFC, the M24LR. If you have any questions or if you are interested in information about this product, please also don't hesitate to contact me. Then we have the field in which we have our products related to short range. There we have Bluetooth products and modules and chips, WLAN chips and modules, as for example the ST modules now. We have Zigbee products and sub-gigahertz products. Then we have our field in which we have all cellular and navigation, global navigation system products, and then we have the accessories in which we have cables, antennas. All of these fields are strongly supported not only by our product marketing, but also by our 100% wireless FAEs, which are in all countries in Europe and which are happy to support you with your project. So if you have any question, if you would like to start any project, please come, give me a call or write me a short email, and then I can connect you to our wireless FAEs. But now, of course, it's all about STMicroelectronics Wi-Fi modules, and therefore I would like to hand over the presentation now to Laura Vanzago. Laura, are you there?
Yes, I'm here.
Okay. So you can start.
Let's see if I'm really able. Okay. Good morning to everybody. My name is Laura Vanzago. I work in STMicroelectronics in Italy, in a division that has a particular target in ST, as we design devices that are turnkey solutions to be used by the customers. Connectivity modules are one of the key pillars of our current product portfolio. The presentation of today is focused on the Wi-Fi modules. The target, the market target that we address can be generically indicated as that of the Internet of Things. Internet of Things, many of you probably already know about it, but is a network of physical objects that are basically connected to the Internet. This object can send or receive instructions and very often use sensors that are used to interact with the external environment. There are many critical semiconductor capabilities in IoT devices, and these semiconductors are sensors, wireless connectivity, analog and ultra-low power controllers, and ST provides a solution for all of them. When we estimate that by 2020 there will be a lot of these devices connected in the world, and today these devices are mostly smartphones, PC, tablets, and networking components. But we believe that by 2020, almost 40% of the connected device will be things. Things will depend on the market that is considered and the application that is going to be developed. And the application, we believe, could be found in the healthcare environment, sport and wellness, industrial, games, smart energy, environmental monitoring, home build automation, and so on. When connectivity is in particular considered, there are many different technologies and communication technologies that can be used in those markets. And so one technology does not probably fit all the requirements that can come up from those applications. And the right technology needs to be chosen by evaluating application trade-offs among range, throughput, power, topologies, cost, interoperability, and so on. We believe that there is good reasons to adopt Wi-Fi in the markets that I briefly described before. And why Wi-Fi? Well, Wi-Fi is one of the natural technologies that have been designed for the Internet. So the TCP/IP is naturally usable with Wi-Fi, with no particular adaptation on it. It is a technology secure, and very often security is one key point when machine-to-machine applications are considered, and it's very flexible over multiple applications. Today we see a great momentum of the Wi-Fi technology because many of the population today has smartphones or other devices that integrate Wi-Fi, and not only in the smartphones, but basically most of us has a Wi-Fi in a home, in the enterprise, in industry, or in the environments for education and government. So there is also one other key point that we see growing every time we talk with customers, and the fact that even in industrial application today, it's not anymore used specific equipment to interface with industrial devices. But what is often done is just to build an application that run on a tablet or on a smartphone. And so the Wi-Fi becomes a natural interface towards industrial application. And that is not always true with other technologies that can have, of course, other advantages, but that very often require the definition of a gateway that is not yet deployed in the environments I've talked before. When we talk about Wi-Fi, we talk of a very complex technologies. There are many Wi-Fi radios. Some of them are integrated in networking equipment that we can have in our house, set-top box or this kind of equipment. And this Wi-Fi, of course, has some features that strengthens the high throughput because they are used for video applications or multimedia application, and so the throughput is the key point. But when we talk of Wi-Fi that can be used on the other devices in the application I've talked before, the characteristics that are very useful for that Wi-Fi are different, and are not the high throughput, but very often are the low cost and the low power consumption. And this because what is important is not to be able to deal with big quantities of data, but with small quantities of data. And the important thing is just to have these small quantities of data that can derive from sensors or actuators or other can be just on the internet cloud. The solution we have is a serial-to-Wi-Fi module. This is the first guy in a family that we plan to increase in the coming months. And the module we have today is a serial-to-Wi-Fi module. So from one side, it operates in the internet cloud with a radio that is 2.4 gigahertz and is 802.11 BGN solution. And from the other part, the module has a serial connection, that is today enabled with the firmware we provide, but also SPI, and then we have I2C and a few number of GPIOs. The module integrates a complete TCP/IP stack plus some application utilities, as for example, very important in many applications, web server, and I will go into this in the next slides. The module is a new, absolutely new production. So this is a preliminary presentation, let me say, in the sense that not all the information related on these modules are today available on the ST website, but the production has already been started, and so you can get in touch, of course, with your Rutronik representative to have samples of this product or even an evaluation kit. Oh, sorry. Okay. Here some a list of key factors and key benefits that we believe our module gives. The first of all, the module is an affordable solution for all volumes. We defined this module to go onto the mass market. It allows to be integrated in many kind of VLAN systems, and this comes from the fact that the radio integrated is radio BGN. It reduces development times for time to market, and the reason for that is that is a fully integrated device, both in terms of hardware and in terms of software. No RF knowledge is required for integration of the module, as everything related on the RF is inside the module, and so the solution is very easy to be plugged in your final application, as the RF and even the antenna or the connector UFL, in case for any reason an external antenna can be more advantageous. Reduces the cost of the final application to be developed, as the module is RF certified, and up to date we got the certification for the CE markets, FCC markets, and Canadian markets, so IC markets. There is no need. It can be very usable with any kind of host processor, in case you have legacy code that you want to keep. And this because the communication goes via an easy to be used 80 layer and goes via UART. So basically there is no need to install any kind of driver on your host, and or there is very often no need to develop some part of the protocol, even at the application level, that can be related to the networking aspect of your application. The component is SMD, so surface mounting, and the size is very small, so it can fit even miniaturized devices with a micro-sized form factor. Allows an easy integration at the application level, and this because, as I said before, it integrates the TCP/IP and some important application layer functions. It's been designed for industrial market, and so the temperature that is supported is in the typical industrial temperature range. Okay, here in this slide there is, I would say, represented the meaning of the part number. So the first two digits are related on our internal codification, meaning that is an SPG product. The second two digits are related on the technology. And then there are three digits that we use to identify the specific design of the module. Then a digit related to the antenna option. A stands for antenna and C stands for connector. And then after the dot, there are two digits that we use to identify the firmware that is supported supported. Up to date, we have one solution with a T layer that we call a T full stack. In the table, it's also specified in detail the two cores, a brief description, and as I said before, we plan to go in full production by the end of this year, but the product is already available, so samples are available and designing can be already started. The positioning. In the market, there is, I would say, a real plethora of Wi-Fi modules with prices very different each other, and but it's important to understand that there is different modules available. Many modules only integrate the radio plus maybe the RF, but all the protocol stack and the application needs to be run on an host that probably is connected via an SPI or via an SDIO, and so you basically need a powerful host to run both the networking and the application. Then there are some modules on the market that only integrates the TCP IP protocol, and in this case, the interface toward the host processor is in the most cases constituted by the sockets, and so basically you need to develop whatever is on top of the transport layers on your host. And then we have other modules in the market, including the solution that we provide, that instead not only contains the TCP/IP, but also contains the application service. And in many cases, you really need a very small host to be connected with the module. In the future, in the next future, we want to add an important capability in the module, in the sense that we plan to open the processor that is integrated in the module to allow the customer to develop the application inside the processor that is integrated in the module, and this can be in many cases a very cost-saving solution for the system. So basically our module is high value in the sense that it provides high benefits, is a very plug-and-play solution for Wi-Fi connectivity for generally speaking IoT markets. The product is a dual chip, and I will show in the next slide probably the main components of the module with integrated software, and the placement is for the mass market. Here the hardware architecture. There are two main components in the solution, and the core of the module is a chipset. CW1100 is its part number, is a chipset from ST. And this chipset has been designed for mobile applications and is fully compliant with the IEEE.11 BGN standard. It is a single chip and a highly integrated solution. It has good performances in terms of power consumption. That is a good point because of the range of application we are talking about now. It integrates the radio power amplifier, and it integrates security blocks for VPA, VPA2 and WEP, and complete BGN modem transceivers. It integrates part of the MAC functionalities and also mechanisms that allow to manage the coexistence between VLAN and Bluetooth. The VLAN software architecture of this radio is split in two parts. I mean the MAC is split in two parts. One is integrated in the radio, and the other one is implemented in the micro, that is also in the module. The micro is an STM32F1, and it presents 60 kilobyte of RAM and 1/2 mega of flash. It stores all the TCP/IP and the application services together with the upper part of the Mac. In the module, we also integrate an external memory of 1 megabytes that we use for two reasons. One is to enable a complete upgrade of the firmware via over the air, and the other reason is that we can support the storage of the web pages inside the module. All the RF parts are, of course, integrated, and two crystal. One is the 32 kilohertz that is used in low power modes of the radio. Here a list of some important modules characteristics. I've already talked about the core devices and about the standard we support. As I mentioned, we have an interface towards the application that is a very simple 80-like layer commands. It integrates complete the shield, the antenna and the connector. As I said, it has a very interesting form factor, as you can derive from the size here reported. The supply voltage is 3.3 typical, and it integrates the voltage regulator, the LPO, and the RF, as I said before. The operating temperature is the industrial one, and we can reach a maximum output power of 18 dBm. And the total flash available is 1.5 megabytes. From the interface point of view, we have the JTAG, the UART. The SPI is available, even if its use is not yet possible with the firmware version that we have today, but it's going to change. The SQRC, and we have 16 GPIOs. Some of them are mapped by the firmware for specific functions. So, for example, we have a GPIO that is used as a link probe. So basically is on when the module is linked with the access point. And we have a GPIO mapped to a power probe, so is on when the module is in on state. towards about the software architecture. Well, basically, all the software, part of the Mac, runs on the STM32 that is inside the module, and this software includes the drivers and the typical standard library drivers of STM32, and the UMAC and the basic TCP/IP functions, plus the application utilities and the AT layer, that is the interface from the user perspective to access the functionalities that are offered by the software that is integrated. Here a list of the main features that are today offered by the software we provide, that is called AT Full Stack. So we provide a rich and complete set of AT-like command that are available via the UART. There is a set also of variables that are used to configure the module, of course, and also the configurability of the variable is via the UART. We implement everything that relates on the wireless security modes that we are able to support today. The IP stack is IP4, and we implement both the transport layers, so TCP and UDP. And from the DHCP and DNS perspective, we integrate the client service of both. It is possible, as I said before, to update the software of the module on field in two different ways, or via the UART or over the air with an AT command. It's possible to open up to 8 contemporary socket clients, both UDP or TCP. We integrate a file system to manage files both in RAM and in the flash. The difference is that in RAM it's possible to create a new file dynamically also when the module is already linked with an access point. So, and this can be useful in case you want to make available to the internet some information that can dynamically change, that can come from the application where the module is integrated. Or is possible to update all the file system that is instead kept statically in the flash, but it's possible to update it, and it's possible to do that via an AT command that connect with a remote device. The application utilities we integrate are web server and HTTP client, plus some other utilities that allow also to do a sort of remote control of the device. We support at the moment 2 system integration modes, the station and the IBSS. So the integration at the application level can be done in this way. So the module can be integrated via an UART, with an host that can be very small and that can be just used to set up a couple of configuration variables in such as the SSID, the security mode, and this kind of stuff. And as I said, every kind of host can be used, even if, of course, we indicate our family. From the perspective of the integration at the system level, we support completely what is the infrastructure mode, meaning that in this configuration there is an access point acting as a central hub to which all the Wi-Fi capable devices are connected. An infrastructure mode, this single access point together with all the associated stations, they are called in this way, is called basic service set. In this configuration, the devices do not communicate directly each other, but they always go via the access point. Each BSS is uniquely identified by a basic service set identification that is generally related on the MAC of the IP, while it's possible to enter in this network by setting the SSID, so the service set identification, that is an informal name of the BSS. In order to integrate our module in this kind of configuration system, the only thing that needs to be done is to set the name of the SSID and the security mode that one of the security modes that are supported by the access point. The other configuration that we support is the ad hoc network, where in ad hoc the station communicate peer-to-peer, so there is no access point in the communication, and there is a direct communication between two devices. In typical ad hoc networks, basically what happens is that one device, and the module is able to do that, creates, I would say, a virtual network that is identified by the specific SSID, even if there is no access point, and all the devices that implement a particular service that is called auto IP can connect to this network. Auto IP is basically a service that allows a device to auto-assign an IP address in a certain range. Not all the operating system support this modality. So the IBSS, for example, is supported by Apple device, but not supported by Android device. To overcome this limitation, we plan to add the complete function of mini-IP to our solution. And so at that point, the module will be able to act as an access point to act as an access point, thanks to the fact that the TCP, DHCP, and DNS server will be also integrated. This function will be available by the end of this year, when also the full production will be completely set up. Here the application utility, the built-in application utilities. So we fully implement a web server, where, as I mentioned, the files that can be HTML, doc, ASCII, or whatever, are stored in the memory, in RAM or in the flash, and this file can be remotely accessed with any remote browser. Then we have the HTTP client, meaning that a remote file can be downloaded via this is an AT command, and so the content of a remote file can be made fully available on the UART and can be processed by the host that is connected on with the module. We implement at the moment some post-like functions, and so it's also possible to remote activate some operations that are enabled by the GPIO or by the circuitry that is connected with the host. And then, as I said, we support up to contemporary TCP/UDP socket connections that are a very great solution if you have, for example, a wireless sensor and you want to publish on a remote server some data in the asynchronous way. Here a detail about the application interface. So basically on the UART what is running are AT commands, and there are multiple categories of them. There are many configuration variables for security, network, application, use mode, and other things. There are a set of status variables that are runtime informations, and these status variables are available both via an AT command, so are available via the UART in case the host needs to treat them in some way, or are also available via an HTML page that can be remotely accessed. And then we have some asynchronous indications that are basically some runtime messages that are echoed on the serial port, and that gives the status of the command and this kind of information. Okay, here just a real list. I'm not going into the details of all the commands that are available, but as I said, there are several categories of commands for utilities. For example, to perform a firmware update, to enable or disable the Wi-Fi device, and so on. There is the possibility to act on the configuration variables via AT commands to get and to set the values, for example, to set the SSID that is useful to connect with an access point, to report the status variables that I mentioned before, for example, via this command, to display the configuration values, and so on. Then we have another category of commands, for example, to manage the network with the ping, with the scan, and to work with the HTTP GET utilities I mentioned before, to do a roam. Then to manage the file, So here, these are the files that are created in the RAM. So it's possible to create a file, to append a content, to delete, to list, and to print the content of the file. And then we have commands to work on the socket. So to open the socket, to write bytes on the socket, to read and to close the socket as needed. And then some commands that are used to handle with the available GPIOs. The evaluation kit that we plan to have very soon in the stock, but for if you want to design in, we can start designing. We can provide an evaluation kit for that, and the evaluation kit will be basically built by two different boards. One is a Discovery F0 discovery board that integrates the module, some LEDs and some buttons, but it's very basic. And the other one is a USB add-on that can be plugged on top of the daughter, providing USB capabilities for connection to a PC. So basically the use modes are here represented. So when you use the daughter board together with the USB add-on, you can plug everything into a PC, and the only thing that you need to do is to, of course, to download the driver for the USB bridge that we integrate in the USB add-on, and then you can use the TeraTerm or whatever other application you want to test the AT commands that are provided by the module. Or the other usage of the kit is to plug the evaluation, the daughter on top of an F0 discovery. An F0 discovery. In this case, you do not need to install any kind of driver on the STM32, and for this usage, we are going to provide an example to show the basic features that we can implement with the module. Okay, so here the summary. The targeted market is Internet of Things. It is a network processor with AT full stack. Samples are available. Full production is by the end of this year, but designing can already start. Okay, I basically concluded my overview. I would like to thank you all for your attention, and I'm ready for questions, if any.
Okay, then from my side, Laura, thank you also for this great presentation. I'm now going to open the phones again for questions. So give me 1 second. Okay, now all phones should be open for questions. So if anybody has a question, please. No questions?
What about the power consumption?
Yes, the average power consumption is 19 milliampere. That depends on if you have to transmit or receive, of course. And then we are going to provide the complete implementation for low power modes.
Thank you.
Okay, then Laura, I have a question. When do you plan to launch the module with the possibility to integrate the custom application inside the module?
It is scheduled for the second quarter of the next year.
Okay.
Yeah.
Thank you.
Okay.
Any other questions?
Can you say something about the prices, roughly? Just the area where it will be placed?
I think this can be.
I think you we have to speak about the price issues direct. So if you have a question about this, please just write me a short email, and then I can tell it to you, because it all depends on the quantity, and yes.
Okay.
Okay. So, if there is no other question, then let me say again, thank you, Laura, for this great webinar, and thank you for all the attendees. Of course, afterwards, so maybe this evening, I'm going to send you this presentation so you can have a look again on it, and then if you have any questions, or if you need samples or an evaluation board, you can directly contact me, and yes, we will see what we can do for you.
Absolutely.
Sorry, Jacob, I've got a question.
Okay.
I was discussing with my colleague about it, and my question is, the power consumption was 19 milliamps. What I heard? 19 of 90.
The average, yes.
It's 90?
Right.
All right, 90, all right. And what is the time? Can you give me an estimation of time to power the module, make connection to the Wi-Fi, make connection to a server, put a file of 2 megabyte there, and close the connection? Is there an estimation of time, how long it takes?
I'm not sure I got your question. Sorry. An estimation of time to connect.
Power up or connect to a server?
To connect to a server, well, is I would say connect with a server. You mean connect with an IP, with an
I mean, so what I want to know is the way power up time, then make connection with a Wi-Fi network, then make a connection to a server anywhere in the world.
Well, we do not have this estimation, in the sense that it's well, the radio is 15N, so we can go up 65 megabyte by second. So the connection is quite fast. We do not see any particular delay with respect to normal devices for this kind of operations.
Yeah, right. My question is because I do not have experience with Wi-Fi over internet.
No, it's. I cannot say that it's immediate, but the radio is very well performing, and so the connection is quite standard. There is no particular delay compared to other Wi-Fi devices for this kind of operation.
Do you know perhaps what the standard timing is?
No, I do not think that the standard fixes this limit in some way.
All right, I have to find out. I will order some samples and then I'm going to play with it. It sounds good. Thank you very much.
Thank you for your question.
Welcome. Thank you, Jacob. That was it.
Okay. Okay, then, if there's no other question, again, thank you. Thank you all. Thank you, Laura.
Thanks, all of you, and have a nice day.
Yes.
Okay.
Have a nice day. Bye-bye.
Bye-bye.